Okay. Good evening to all. Sorry for being late. Sakshi, Abhay, Anika. Okay. Kalol, Ralam, Mansi, Vadehi, Siddharth. All of you, good evening. Collector Shaiba? Ralam? Who is Collector Shaiba? First tell me, how are you all? All good? Okay. So now we will discuss today the question number 25. What are the major differences between metals and non-metals based upon chemical properties? बेबू क्या कर रहे हो? So property, metals and non-metals. Yes. So first property is it? Okay, so first property is nature of oxides. So tell me, what is the nature of oxides of metals and non-metals? So metal oxides are generally very good. Metal oxides are generally basic. Metal oxides are generally basic. So tell me, what are the exceptions? So keep in mind, zinc oxide and Al2O3 are amphoteric. Amphoteric means they can act as acid as well as basic depending on the conditions. Okay. Now, non-metal oxides are generally acidic. Non-metal oxides are generally acidic. So, what are the exceptions? Can you tell? Exception. Very good. Amphoteric, which can act as acid as well as basic. Good. So, non-metal oxides are generally acidic in nature. So, what is the exception? Is there any exception? Yes, anybody? Zinc, aluminum, it's okay. They are here. In this case, so keep in mind NO, N2O and CO are neutral. So these are exception, because nitrogen and carbon both are non-metals, but nitric oxide, nitrous oxide as well as carbon monoxide, they are neutral. neither acidic nor basic. Neutral means neither acidic nor basic. Okay. Second, electrochemical behavior. Electrochemical behavior. Yes. Yes, madam. हाँ चल रहा है वीडियो, मम्मा के मोबाइल में देख सकते हो आप। मम्मा के मोबाइल में आएगा ये वीडियो, ठीक है। मेरा बेटा पूछ रहा है वीडियो चल रहा है। ओके, तो इलेक्ट्रोकेमिकल बिहेवियर, यू नो, metals lose electron to form cations. Means in electrochemical behavior they generally form cations, right? Means metals are electropositive. Metals are electropositive. Non-metals gain electron to form anion. Means non-metals are electronegative. Non-metals are electronegative. Electropositive in nature and electronegative in nature. Right? Now, third, action with dilute acids. Yes, that you know. Action with dilute acids. Bolo. Okay, Fiaz Ali, I will definitely do that. Very good. So, action with dilute acids. So, active metals evolve H2 gas with dilute HCl or dilute H2SO4, dilute acids. Non-metals do not evolve H2 gas with dilute acids. Okay, now fourth one is nature of compounds. Is it visible? Yes. Yes, what is the nature of compounds? Compounds of metals are generally, yes, very good. So compounds of metals are mostly ionic in character, are mostly ionic, and compounds of non-metals are generally covalent. Okay, ionic compounds of metal compounds are generally ionic, and non-metal compounds are generally covalent. Then next is oxidizing and reducing character, or reducing nature. So metals are, yes, tell me now, metals are reducing agents or oxidizing agents? Nature of compound, beta, nature of compound means, like, you know, NaCl, salt means it is ionic, but HCl, it is covalent. There is a covalent bond between non-metal and non-metal. Okay, H and Cl, they form covalent compound, but metal and non-metal, they form ionic compounds. Okay, so metals, compounds formed by the metal, obviously metals form compound with non-metals. Metal cannot form compound with metal, right? Because with metal and metal they form alloy, or if same type of metals are there, they are simply metal. If two different metals are in the same mixture, that means it is an alloy. Okay, but metal always form compound with non-metal. So metal and non-metal form ionic bond, and non-metal always form with compound with non-metal. So non-metal and non-metal forms covalent compound. There is a sharing of electron. Yes. So tell me now about oxidizing behavior. Oxidizing behavior. Ralam, got it? Yes. What about oxidizing behavior? Fast. Oxidizing behavior. Very good. Metal, non-metals are reducing. Beta, oxidizing agent means the compound or the element which can oxidize other and itself gets reduced. Difference in, see, oxidizing agent. Oxidizing agent. element or compound or species which oxidizes other and itself gets reduced, means which gain electrons. And reducing agent, just opposite, the element or compound or species which reduces other and itself gets oxidized, means which lose electrons. So tell me, oxidizing and reducing, which one is stronger reducing agent? Oxidizing agent means which can gain electron. So which one gain electron? Metal or non-metal? Amog, he is my son. Very good. So, metals are good reducing agents and non-metals are good oxidizing agent. Because no metals lose electron, therefore it forces others to gain it. It forces others to gain electron because it itself gets oxidized. So force others to gain means reduce others. That's why it is a reducing agent. Chlorine itself gain electron. So it forces other to lose electron, means oxidize other, therefore it is an oxidizing agent. Non-metals are good oxidizing agents, metals are good reducing agents. So this is all about the difference between metals and non-metals based upon their chemical properties. Okay, and this is 25th question of our exercise of chapter 3. Now question number 26. Question number 26. Would you expect the ionization enthalpies of two isotopes of the same element to be different, to be same or different. Justify your answer. So I will sit and see your answer first and then I will reply. Yes, tell me. Very good, Vadehi, Ranam, Siddharth. There is a change? Away, right? Siddharth, it is almost same. One question asked by Siddharth first, I will reply that carbon, is it a reducing agent or oxidizing agent? Actually, in the question, we are talking about general. That carbon, though it can act as a reducing agent in some cases, but being a non-metal, its first and foremost thing is to act as an oxidizing agent. Okay, but you know, carbon, when it is used with zinc oxide or sometime, you know, zinc, then we get zinc plus carbon monoxide, or sometime zinc oxide can be reduced by carbon. So means carbon can act as a reducing agent, but in the properties we are talking in general. Specifically, sometimes, you know, even non-metal can be oxidized, right? So keep in mind, we are talking about general properties. Specifically, if we talk about carbon only, then there are a lot of things. Okay, Siddharth, I think you got the point. Yes, there is an answer. Okay, same. So let us discuss this question now. Would you expect the ionization enthalpies of two isotopes of the same element to be same or different? Most of you answered. Very good, Mansi, Sakshi, Vadehi, Ralam. Yes, metal is का oxidation or reducing agent. Yes. Okay, so let us focus on this question. Actually, ionization enthalpy depends on size, nuclear charge, and electronic configuration. And for isotopes, all of them are same. That's why ionization enthalpy of isotopes is same. That's it. That you have answered. Very good. Now question number 27. In question number 27, question is use periodic table. Use periodic table to answer the following questions. First question is, identify the element. Identify the element with 5 electrons in the outer shell, subshell. Outer subshell, not shell. In the outer subshell. Second, identify the element that would tend to lose 2 electrons. Identify the element that would tend to lose 2 electrons. Actually, it is outer shell only. Sorry. Outer shell. Okay. Identify the element. Identify the element that would tend to lose that would tend to lose 2 electrons, that would tend to gain 2 electrons. So these are the 3 questions. Yes. Tell me, element with 5 electrons in the outermost shell. Thank you, Jyoti Sharma, for the appreciation. Yes, tell me. NS2P. I didn't get Ralam. Group 17. Wrong. I said outer shell. Identify the element with 5 electrons in the outer shell. So, elements belonging to nitrogen family. You know, in nitrogen family there is NS2 and P3. You are right, Ralam, if it is written outer subshell. Okay. In the outer shell I removed some. Okay. If it is subshell, then it obviously the answer is group 17. If it is outer shell, the element belonging to nitrogen family, that is group 15. Okay. For example, nitrogen, phosphorus, arsenic, antimony, okay, even bismuth, outermost shell. Okay. Group 15, beta, group 15. Okay. Now identify the element that would tend to lose 2 electrons. Yes. element that would tend to lose 2 electrons. Right. So, an element that would tend to lose 2 electrons. So, elements belonging to alkaline earth metals. Elements belonging to alkaline earth metals. That is group 2. For example, beryllium, magnesium, calcium, strontium, barium, okay, even radium. Okay. Now identify the element that would gain 2 electrons. So obviously, the element which after gaining 2 electrons acquire noble gas configuration. So elements belonging to oxygen family. You know, oxygen family, that is group 16. For example, oxygen, sulfur, selenium, tellurium, polonium. Okay? So these are the answers. I think you are satisfied by these answers. Simple. The element with 5 electrons in the outermost shell. So obviously nitrogen, 2, 5. Okay. So whole nitrogen family is like that. Element that would tend to lose 2 electrons. So you know, alkaline earth metals after losing 2 electrons acquire noble gas configuration. Right? And the element that would tend to gain 2 electrons. So you know, oxygen, when gain 2 electrons, it acquire noble gas configuration. So whole oxygen family is like that. Right? Okay. Right. Very good. Now question number 28. 28 is the increasing order of reactivity. The increasing order of reactivity among group 1 elements is lithium less than sodium less than potassium less than rubidium less than cesium. Whereas among the group 17 elements, whereas among the group 17 elements, it is fluorine is greater than chlorine, bromine, iodine. Explain. So you can say in case of alkali metals, reactivity increases down the group, but in case of non-metals, reactivity decreases down the group, because you know it is sodium, potassium, rubidium, lithium, sodium, potassium, rubidium, cesium. then it is, fluorine, chlorine, bromine, iodine. So here reactivity down the group decreases. In this case it increases. Why is it so? Yes. Tell me. बेटा नॉन मेटल की रिएक्टिविटी क्यों नहीं होती? No, there are very easy chapters. Okay. Very good. Siddharth is right. Siddharth hit it right. See, metals reactivity. Metals reactivity. Yeah, we can write reactivity of metals. Reactivity of metals is due to its tendency to lose electron, because metal can form cation, so its electron releasing tendency means reactivity of metal is proportional to its electron releasing tendency, and which is related to, which is linked to its ionization enthalpy, which and ionization enthalpy decreases down the group. That means energy required to remove the electron decreases. That means it is easier to remove electron as we go down the group. Electropositive character or metallic character increases down the group, and so is the reactivity. Means ion enthalpy decreases down the group, so its reactivity increases. Done? So this is about reactivity of metals. Now tell me, reactivity of non-metals. Reactivity of non-metals is related to its electron accepting tendency. This electron accepting tendency. That means which is linked to electronegativity and electron gain enthalpy. So as we go down the group, electronegativity decreases or electron gain enthalpy also becomes less negative. That means its electron accepting tendency decreases as we go down the group, and so is the reactivity of non-metal. So if we conclude, first I will write that reactivity as electronegativity as well as negative value of electron gain enthalpy decreases down the group. So reactivity also decreases because its electron gaining tendency decreases, okay, as we go down the group, okay. And so if we conclude, we can write that reactivity of metal is related to electron losing tendency, electron donating tendency, and reactivity of non-metal is related to electron accepting tendency, electron gaining tendency, right? Is there any doubt in this? Beta, reactivity means when metal react, it form cation. When non-metal react, it form anion. See, if there is a reaction between sodium and chlorine, you know sodium is metal and chlorine is non-metal. So when sodium and chlorine react, we get sodium chloride, right? So what happened? Sodium form cation and chlorine form anion. That means metal is reactive if it forms cation easily, and non-metal is reactive if it forms anion easily. That means those metals are more reactive which can lose electron easily, and those non-metals are more reactive which can gain electrons easily. Means more is the electronegative nature of non-metal, more is its reactivity, and more is the electropositive nature of metal, more is its reactivity. Done? Got it? So metals are reactive if their electron losing tendency is more, and non-metals are reactive if their electron gaining tendency is more. Okay? Any doubt? Yes? Others? Mansi? Siddharth? Jyoti? Mansi? Yes, Sakshi? Vadehi? Anyone other? Mohak? Okay, Anika, no doubt, huh? Abhay, very good. Okay, so let's do next question. Next question is, write the general electronic configuration of S, P, D and F block elements. General electronic configuration of S, P, D and F block elements. Yes, tell me. What is general electronic configuration for S block elements? For P block elements, for D block elements, for F block elements. Yes. Yes, yes, please. First, very good. Siddharth, it is NS122. Noble gases, inert core, sorry, NS122, and N varies from क्लास बोलिए हेलो 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 yes, very good Vaidehi. It is NS1 to 2 and N varies from 2 to 7. Okay. What about P block elements? Very good. It is NS2 NP 1 to 6 and N varies from again 2 to 7. Yes, what about D block elements? Wow, Ralam did for all. Anushka Rajput, N-1 D 1 to 10 and okay, Mansi, good. It is N-1 D 1 to 10 and NS1 to 2, or sometimes we can write 0 to 2 because there is palladium, only one, that is palladium, which is 4D 10 and 5S 0. Okay, so we can write 0 to 2 as well, but generally it is 1 to 2 and N varies from 4 to 7. Okay. Now F block elements. So for F block elements, it is N-2 F 1 to 14, N-1 D 0 to 1, NS 2, and N varies from N is either 6 or 7. Lanthanoid and actinoids. Okay, so this is for D block elements, F block elements, sorry. Right now, next question number 30, last question of the day. Question number 30 is assign the position of the elements, assign the position of the elements having outer electronic configuration NS2 P4 for n equal to 3. Second is n minus 1 D 2 NS2 for n equal to 4. And third is n minus 2 F7 n minus 1 D 1 NS2 for n equal to 6 in the periodic table. Yes. So assign the position of the elements having these electronic configurations. Third period, 16th group. Very good, Mansi. Great effort. Yes, Abhay, P block element, good, very good. That's right. And what is the name of the element? Name of the element. First, what is the name of the element? Period third, 16th group. So what is the name of the element? Very good. Sulfur. Ralam, not selenium, it is sulfur. See, in first case, first of all, as n equal to 3, so element belongs to third period, as last electron entered in P subshell, so it is P block element. Then third thing, as, not as, so group number for P block elements is equal to n plus number of NS and NP electrons. So it is 10 plus 2 plus 4. So 16. So it belongs to 16th group. Okay. Okay, we can write below it. Is it possible? Yes, we can write here. So its electronic configuration is at is 3s and 3. That means before that it is neon. So electronic configuration is neon, then 3s2, 3p4. So its Z is 16 and element is sulfur. Right? So this is for first one. Okay? Now second. This is for first. let's go for second. Now in case of second, as n is 4, so it is fourth period element. And as last electron entered in, as last electron entered in penultimate means n minus 1. Penultimate D subshell. So it is D block element, right? And group number for D block is equal to number of n minus 1 D electrons plus number of ns electrons, right? So that is equal to 2 plus 2. That means it belongs to group 4. And electronic configuration is, okay, you can write here. Yes, we have that space. Electronic configuration is, up to argon it is 3s2 3p6, then it is 4s2 3d2, 3d2 4s2. That means 18 plus 2 20 plus 2 22. So Z is 22 and element is, yes, what is the name of the element? It should be titanium, right? So it is titanium. Okay. So okay, and it's fourth period element, right? Okay, now n equal to 6, so it becomes 4f7, 5d1 and 6s2. Okay, so as n equal to 6, so it is 6th period element. Then as last electron entered in F subshell, कौन सा F subshell? Antepenultimate, antepenultimate means n minus 2. Antepenultimate F subshell, so it is F block element, and F block elements belongs to group 3. So it is in third group. This element is in third group. Okay. Now configuration is 4f7, 5d1, 6s2, F block and lanthanoids. Okay, so it is xenon, 6s2, 5d1 and 4f7, or we can write other way around like xenon, 4f7 5D1, 6S2, right? And xenon is 54. 54 plus 7, 61, 62 and 64. That means Z is 64. So Z64 is gadolinium. Element is gadolinium. You can write element is gadolinium. Okay. 6th period, 3rd group, F block, Z64, and name of the element is gadolinium. So that's all for the day. So let's call it a day. Thank you very much. Good night all. Jai Hind, Jai Bharat. Very good Anushka, very good Ralam, Mansi, Sakshi, bye beta, Siddharth. Good morning, beta. Good night. Okay, beta, bye. Bye, Abhay. Okay, Mansi, bye bye. Okay, Anika. So, okay, so I'm signing off. Bye, Abhay.